Hey folks, Anthony Shimana here, Senior Consultant with Industrial Logic, and today I'm going to be working through the Roman numeral TDD Kata, so feel free to follow along if you'd like. Today I'm going to be doing it in Kotlin, but you can do it in the language of your choice. If you do want to practice it in Kotlin, we'll walk through the build Gradle file, so you can use the same dependencies and libraries that I'm using. So to get started, why don't we walk through the instructions for this kata? So we're going to be converting decimals into Roman numerals using test-driven development. And a few of the instructions for the Roman numeral conversion. So the Romans wrote their numbers using combinations of the following letters. 1 is I, 5 is V, 10 is X, 50 is L, 100 is C, 500 is D, and 1000 is M. Numerals are summed, right? So 3 would be III, 7 would be VII, 22 XXII, and 351 would be CCCLI. And then the special case here is that no numeral is repeated more than 3 times in a row, right? Instead, we put a smaller number then in front of the larger number to subtract. So for example, 4 is IV, 9 would be IX, 29 XXIX, 49 XLIX, and 900 would be CM. Okay, so let's get started. If you do want to practice this in Kotlin, I can show you my build Gradle file here. Kotlin has quickly become one of my favorite programming languages, and certainly my favorite that targets the JVM. It's really a joy to work in. So I will be using JUnit 5 as my XUnit framework. So you can see we have the Jupyter engine here and the Jupyter API. I'm also going to be using parameterized tests in JUnit 5. So that is this line here. And then also I'm going to be using a Kotlin Fluent assertion library called Cluent. And that's this one right here. All right, so let's get started. We'll go over to our test. This is my first test, my true equals true test, which is just to make sure that we have everything wired up properly. So let's go ahead and run that. Okay, so that passes. So we're ready to get started. So when doing TDD, my first step is really identifying what is that first test that I want to write. In industrial logic, we call it identifying the essence. When I'm doing TDD for an algorithm, what is that first step that's going to help me start to think about my algorithm? This first test is going to help me figure out what the object API is, right? What is the signature for the object that I want to work with? So I think really the simplest place for us to start is just the one case, right? So we can say convert 1 to I. Now this might seem odd to you if you've never done Kotlin before, but in Kotlin we can use backticks to put spaces in our methods. It's not recommended for production code, but we can do it for tests so that they read a bit better. So here we're going to say convert 1 to I, and now what we'll do is replace this. We can say Roman numeral. That'll be the name of our class. Convert will be the method. Pass it a 1, and then here's our Cluent assertion. We can say is equal to, or should be equal to I. That's our first test. We can clean up our extra import here. You can see here, obviously, if we ran our test, they wouldn't work. Because Roman numeral doesn't exist. So what we can do is just do an Alt-Enter here and do create Roman numeral. We want to extract it to a separate file. Now here I'll just move it out of the test directory into my main directory. Okay, we don't have to add it to Git. Let's zoom in here, but I can close out of those, and now I can go back here, and you can see now convert doesn't exist, so we can do the same thing. Alt-Enter, create function, we'll call it decimal. We know we want it to return a string, so I'll change the type here, and here we can just say return empty string for now. We can go back, and now you can see should be equal to is now red, so we can do an Alt-Enter. There we go. So now I think let's run these tests, and we should get a test failure for the right reason. Okay, so if we zoom in here, we see expected I, but actual, we got nothing. So our next step is to do the simplest thing that can possibly work. And this is the thing that seems odd to a lot of people when they first start doing TDD. It seems almost silly or a waste of time. But the simplest thing I could possibly do is just return an I directly here. And again, this may seem odd to you the first time you do it, but this is a really important step because it's going to prevent us from writing speculative code or writing code that is too complicated. We're really just focused on the simplest thing that can possibly work, and then we can improve our design in our refactoring steps when all of our code is working. So let's rerun our tests. Right. And that passes. Okay. So let's go over for our second test. So for our second test, I'm going to copy this test. And the fact that I'm copying and pasting this test makes me realize that I probably want a parameterized test instead. But I'm only going to do that refactoring. Much like the production code, I'm only going to refactor the test code when all my tests are passing. So we'll go ahead and start with introducing the duplication, and then we'll get rid of it, which is another refactoring pattern. Introduce as much duplication as possible, and then we can extract out the commonality. So that's what I'm going to do here. So we're going to say convert 2 to II, and this should be 2. Should be II, and now we can run all of these tests. Okay, so one passed and one failed. Expected 2, but was expected II, but was I, which is what we would expect. So now here instead, I can do something like if decimal equals 1, we can return I, else we can return II, and that should make both pass. And yes, there we go. Both have passed. It's a little small here, but we can see that both tests have passed. So now let's get rid of this duplication by introducing a parameterized test. So what I'll start with is, let's just comment out this one for now. And instead of test, we use a parameterized test annotation. Add it there, and we'll end up getting rid of this one. And then this is, you see that yellow squiggle, it's because we haven't defined a source yet. So we're going to do CSV source, and add that. And here we just start passing in our parameters. So here we're going to have one I, and then the second one, and we'll just line these up, 2 II. Now we have to pass those as parameters. So we can say decimal, and it's an int. And we can call this one expected, and it's a string. And now here we just use those parameters in the test. This will be decimal, and then this becomes expected. Now let's run those tests. Excellent, so they both pass. So now we can delete this, get rid of that duplication. And there's one thing that I don't like here, right? This test still says convert I to 1, so we could fix that and just call this convert. And that should obviously still pass since we just changed the name. But there's one more improvement we can make. So parameterized test annotation, it also has a name attribute. And what we can do for the name is there's a couple special ways that we can access the parameters from the name. So here I can say should convert 0 to 1. So curly braces 0 and 1 are the different parameters here. So now if we run this test, I know the output here in this window is a bit small, but it does say Roman numeral test convert should convert 1 to I, should convert 2 to II. Okay, so I'm pretty happy with that so far. So I think the next step here, we just have this if-else statement, is Let's go to the third case. So here we can just duplicate this line. And we'll run this test. And again, this is just the next simplest thing I can do that's going to force me to progress my algorithm forward. Okay. So now instead of doing this, I could loop. So I could say for I in 1 to decimal. I can create a string. So var is a mutable variable. Here I can say result plus equals I. And here I can return result. So that's really the simplest thing I think I can do. Let's run our test and see if that covered all the 3 cases. And it did. Okay, great. So let's go back to our tests. So I could go to 4, but if you remember from our README here, 4 is our first special case. And I don't think I am ready to go to the special case yet. So let's just go to 5. We'll go to the next Roman numeral character. Okay, I think this should fail. Okay, and it did. Okay, so I'm just thinking about what's the simplest thing I could do here. I could say if decimal equals 5, we can return V. And that's the simplest thing I can do to get this test to pass now. Great. So what is the next step that I want to do here? So I think the next step is going to be summing both V's and I's. So let's do a case here. Where we have, let's say, 7. So that would be VII. And let's run that. Okay, and that test has failed. So what will we need to do? Well, first we'd have to see if the decimal is greater than or equal to 5, and we wouldn't want to return 5. We'd actually want to add it to this result. So let me move this line up here, and here we can say result plus equals. And that may be enough. If it's greater than 5, we want to add 5. But are we missing anything else? Well, the issue that I see is we need some way to decrement decimal, right? To know how many i's do we need to add after we add the v. So I would think we could decrement decimal, but there's an issue with that. And we'll show you here. If we try to do decimal minus equals 5, we're going to get an error here, and it's going to tell us that decimal cannot be reassigned. It's immutable. So one thing we could do instead, let's undo that. One thing we can do instead is just create an immutable version of the parameter. So I think the simplest way to do that is to rename the parameter here. And so if we don't want to use decimal, the terminology in the instructions in the README, they called it Arabic number. So what if we change this to Arabic number? And the first thing that we do is instead of a immutable integer, say var decimal equals Arabic number. Now decimal can be reassigned. And so here we can say decimal minus equals 5. And then here we can say decimal minus equals 1. Let's run our tests. Okay, great. So we now have that case covered. So I think for my next step, let's go to 10. 10 is x. I don't believe our algorithm will handle that yet, so we'll run our tests and see we have a failing test. And now let's go back over here. So I could see a pattern forming, but I'm not going to do anything about it just yet. Let's just say if decimal equals 10, return x. Excellent. Okay. So I think my next step, the next test that I want to write that's going to push my algorithm forward is going to be a case where we add to the 10 a 5 and some number of 1. So let's go with 18. That's going to be x, v is 15, 16, 17, 18. Let's make that the next test. Okay. So at this point, I am actually going to introduce the duplication here because we have a failing test, right? So I'm going to do the simplest thing that could work, and then we will eliminate that duplication on our refactoring step. Okay, so now I think that this code is nearly identical, right, except for the decimal value and the Roman numeral value. Let's run our tests. Excellent, they all pass. So my next step here is going to start refactoring away this duplication that we just introduced. Now, I could extract this out in a private method and pass it 2 parameters, but I think I could actually simplify it further by looking at a different data structure. If we had a map that mapped the decimal value to the Roman numeral value, we could just iterate over that map. So I think that's what I'm going to do here. So let's say private val, we can call it Roman numerals. We'll create a map here, and I'm going to say, because we start at 10 and go to 5, I'm going to say 10 to x, and 5 to v is going to be our map. And now what can we do here? So what if we comment this for now? And what we can do here is we can actually iterate over the Roman numerals. We can say Roman numerals for each. And actually, let me start it this way. We're going to say entry and say if decimal greater than or equal to entry dot key result plus equals entry dot value. And then we're going to decrement decimal, right? We're going to reduce decimal by entry dot key. Let's run that test. Awesome, they all pass. So first thing we can do is delete this duplication. We've now gotten rid of that duplicated code. We still have the ones case to deal with, but we'll come back to that. The one thing I wanted to show here is the parameter for the lambda function is entry. Well, there's something interesting that Kotlin provides. It actually provides an implicit variable. So we can say replace explicit parameter entry with it. So it is an implicit parameter for a lambda function. So let's do that. And that just cleans up our code a little bit, and we can rerun our test. Okay. So going back to our tests, there's a case here that I see that we're not currently covering. And let's take a loop at our code. Now, we are iterating over our map. So what happens when we have to stay on the same map entry for more than one time through a loop, right? We haven't had that case yet for 5 or 10, but if we come back here, I think if we do 20, that should expose the problem. So let's run our tests and see. Yeah, and 20 fails. And again, that's because we only loop over the each map entry one time. So what is a simple way we could make this test pass? So we iterate each time through our map entry. What if instead of this being an if, we just make this a while? Awesome. That made all of our tests pass. So it was simple, setting up the case, and this makes me feel good about the algorithm that we're producing, that we could simply just replace an if with a while loop, and now we are covering that additional test case. Okay, so where should we go next? I think I'd like to deal with the ones now, the I case, because we have this kind of special code at the end to handle it. But now that we are looping over the values inside of our loop for each of the map entries, I believe that we could just comment this out now and just add 1 to our map, and that should work. And rerun our tests. Awesome, and they all pass. So now we're getting down to a very simple algorithm here that works for all of our cases. Okay, so now let's start thinking about our next test case. So at this point, I think there's a few different directions we could go. We could either go to our special cases, or we can keep going to the next new Roman numeral. And I don't think one is better than the other at this point. I think we have a pretty good algorithm so far. So I think let's go with 50 next. So we'll make 50. 50 was L. And let's run our tests. Okay. And that should be as simple as just adding to our map here. Awesome. So one of the things I want to mention about test-driven development, when we do test-driven development, our goal isn't to write every possible test case that we can ever think of, right? We're writing tests to drive our software design and implementation. So really, we don't want lots of tests that are just going to execute the same exact code path, right? We know, we call this gray box testing, right? We try to treat our objects like black boxes, but we know something about those objects because we're building them. So we don't need lots of extraneous tests that just test the same flow through our code, right? And whether if the flow of the code isn't different, or if the data isn't very different, then we don't need to add all of those extra tests. However, I take a bit of a different approach with algorithms, because as we come up with more interesting algorithms and we can simplify them for more cases, we may want to come back and write some test after that may never fail, right? We might want to write those tests just to make sure that we're covering those cases, and I think that's okay. So let's try a couple of those here. And what we'll do is we'll do a TDD practice, which is calling our shots, right? When we test drive our code, sometimes we like to say how we think the test is going to fail. So here we can say whether we think our algorithm will handle this case or not. So let's do something that sums a number larger than 50, but it doesn't handle any of our special cases yet. And we think it should pass, but we'll just verify that. Let's start here. Maybe let's try 77. So that's 50. 60, 70, 5, 6, 7. Pardon me. So let's run that. And I believe this will pass. Excellent. And it does. So we could delete that if we didn't think it was adding value, but I think it's simple enough that we could leave it for now. So now I want to start thinking about my negative, or our special cases rather, the subtraction case, right? So if you remember, if we go back to our README, we have 4 and we have 9 are our first two examples of numbers that we don't ever want to get 4 numbers in a row, or 4 Roman numerals in a row, so that we subtract, right? And we do IV for 4. So I think our first test could be for 4. So here I can just duplicate this line. 4 IV. And let's run that. I believe this is going to fail. Okay, great. So now let's come back and look at our algorithm here. So I think there's a couple options here. The first one is we can kind of work through this loop, and when we get here, we can detect if we have 4 numbers in a row, right? So if we have 4 ones in a row, we can replace those. We can go, forward 1 entry in the map, get the 5, and put the 1 in front of it. But that's going to really complicate our algorithm, right? And we could do the same thing for 9. We would have to identify that the 4 ones are coming after a V, and then go up to an X, and then take 1 away from it. And that algorithm is going to be complicated, right? When we get to something like 100, how do we handle that case? And I can see this code becoming much more complicated. So there's one thing, and that's honestly the first time I did this, this code kata, I did kind of brute force it and realize that that was probably not the best solution. So there's one other thing we can do. We can actually treat those special cases, there's not that many of them. We can treat them like they're not special at all, and just put them into the map. So if instead of just doing all of that extra processing, once we know we have 4 Roman numerals in a row, we can just have 4 here and map that to IV. And I believe that should work. So let's run our test. Awesome. And so the beauty here is that we've not had to complicate our algorithm at all. We just had to take a special case and treat it just like a new Roman numeral in our map. Okay. So I know 9 is our next special case, so let's put 9 in. That's IX. 9 fails. We can come back here, and again, we can just do the same thing. We can add 9 to our map. Excellent. So before we go on, we can kind of go in 2 different directions at this point. We can keep adding special cases or go back to the new Roman numerals. Or we can choose to do like a test after. And I think one test that might be valuable to see is we can put 2 special cases together. Well, actually, no, we can't yet. We don't. Do we have enough to put 2 special cases together yet? I'd say let's keep going. And I'm not so sure. I'm pretty confident in our Roman numerals, and I actually don't know how valuable that is. So I would say let's go to 100 next as our next test. So come down here. If we feel like we want to put 2 special cases together, we can do that. Once we get to 100, we should be able to do that if we needed to. Okay, so let's say 100 is C. But it got LL. Okay. And now that I'm feeling confident with our algorithm, let's just go through and add, we have 100, so we can add 500 and 1,000. So let's do 500. 500 is D. Okay, and now I'm just going to come and add the 1,000 case. Thousand is M. Okay, and it's, you can see here, it came up with DD instead. So we can come back here and we can just add 1,000 to M. This line's getting a little long, so we can just choose somewhere to break it for now. Let's do a format on that. There we go. That looks a lot better. Okay. So I think our next step here is now to go through and start looking at our other special cases. So we handled 9. We handled 4 and 9. The next special case is we just increment by 10. So 40 and 90 is another special case. So let's do 40. Simply duplicate that line, 40. What's 40 going to be? So we take 10 away from 50. And again, we're just going to add that to our map here. So I'll do it after 50, and I'll say 42. What was it again? XL. Right, 10 away from 50. Excellent. Now let's go to 90. And these don't, our test cases don't have to be in order, but I think they read better that way, so I will keep putting the numbers in increasing order here. So for 90, C is 100, right? And we want to take 10 away from that, so that's XC. And that one will fail. Okay. So our next, I think we're coming down to the last few special cases, and those would be 400 and 900, right? So we just kind of add another 0. So let's do 400. So for 400, CD, right? 100 minus 500. Or if I should say 500 minus 100. Okay. Now our last special case is 900, right? So M is 900. We subtract 100 from that, and that's our 900 case. One failing test. So our algorithm produced DCD. Now if we go back here, say 900 to CM. Okay, so it looks like it's formatted well. Come back here, and now we have all these test cases, but again, I'll kind of go back to my earlier comment when we first added the first two special cases. Maybe let's try a few to add, or at least one to add several test cases together. So one good one is maybe 3,994. 3,994 is a good one, right? So that's got a few special cases in it. So let's try 3,994. So 1, 2, 3. That's 3,000. Then CM, that's 900. XC, that's 90. 94. And I believe this should work. And it did. Excellent. So I believe at this point we've covered all of our Roman numerals up to 3,999. I think I kind of skipped past that, but there's a note here that we will only support conversions up to 3,999 because beyond that, some of the rules change. So at this point, I believe we would handle all of those cases. And this is the algorithm that we were able to test drive, and it's a very simple algorithm. And we learned that by treating special cases like new Roman numerals, we were able to keep this algorithm very simple. And the interesting thing to think about here is, I know I probably would not have come up with this algorithm if I wasn't doing test-driven development. So test-driven development absolutely can be used for algorithm development. So that's it. That's all I have today. Take care, everyone, and hope to see you next time.